aim. If I gave you a problem like 7x equals 21 on the exam, you'd be pretty happy. Like, oh, hey, I can solve that one, no problem. Now, most of us, myself included, seeing something like that, would divide both sides by 7. But equivalently, you could also think of multiplying both sides by something. What would you multiply by? No. What would you multiply to get the x by itself? 1 over 7. So basically the reciprocal of 7. Because the reciprocal of 7 times 7, well, something times its reciprocal gives you 1. So you get 1x equals 3, or just x equals 3. We're going to do that with systems of equations. Sort of. As close as we can. We're going to introduce something called a matrix, and then use that to solve a system of equations. Let's start with problem number 30. Problem number 30 gives you x plus y plus z equals 6. X plus 2y plus z equals 8. And finally, x plus y plus 2z equals 9. So the first thing I'm going to do is I'm going to replace this system of equations with some matrices. What we're trying to do is bridge the gap between something that you write on a piece of paper and something you can put into your calculator. So I'm going to start by creating what I call matrix A. And A is just going to be the coefficients on the left-hand side. So in the first row, it'd be 1, 1, and 1. What do you suppose the second row is going to be? 1, 2, 1. And the third row, 1, 1, 2. Okay, not a really complicated system. And now I'm going to write x, y, and z. Without getting into matrix multiplication or anything like that, I'm just going to call this matrix capital X, x, y, and z. So I'm turning this into a matrix system of equations. The last thing I need to do is put something on the right-hand side. So that right-hand side I'll call matrix B. What do you suppose should be my right-hand side? 6, 8, 9. I grew up in Troy for a while, and that used to be the prefix for a lot of phone numbers. There was 6, 8, 9. In any case, AX equals B. That's my system of equations, kind of written in this matrix form. Now don't copy this down. It's not really going to help you out much, but what I'm going to suggest is that we're going to do the same thing with matrices that we did with that little bitty example that I started out this section with. And that is, I'm going to multiply both sides by the inverse. I can't divide by a matrix. It's not something that you can do with matrix algebra. But you can multiply by the inverse. And like I said, don't copy this down. Oops. Let's see, I need A inverse. Basically, I'm going to do the same thing to the left and right hand sides, and that is multiply by A inverse. Now this is going to give you the matrix equivalent of the number 1. And that essentially is your solution, is A inverse times B, whatever that inverse matrix is. Now our goal is to use a graphing calculator to do all this work for us. This is the work that you're going to do on your graphing calculator. So what you're going to have to do is, first of all, enter matrix B. It's going to be enter A and B, and then do this calculation. But it's mostly going to be pushing buttons. So let's see if we can't make that work. So on the left-hand side of your calculator, right above the x inverse key, what do you see? Matrix. How do you think I get to that menu? With the second key. So second button, and then press the the X inverse key, so that gets you to a matrix menu that looks like this. Now, if you have some numbers here or not, it just doesn't matter. It does not matter. What we want to do is cursor twice to the right or once to the left to get to the edit menu. And we're going to edit matrix A. So is everyone with me? Press enter and it'll put you at the top here. Now if you got some stuff here, don't worry about it. We want to enter a 3 by 3 matrix. 3 rows, 3 columns. When you talk about matrices, their dimensions are always in that order. Rows first, then number of columns second. So let's type in those numbers now. So if you type in a 1, then press enter, it'll move you over to the next spot. 1, 1, 1, 1, 2, 1, 1, 1, 2. So pretty quickly you should be able to enter in that matrix. So everyone have matrix A entered. It's important that you stay on the same page. I don't want to leave anyone behind here. Let's exit this editing. So to exit, press the second button, then the mode button to quit. We're going to do the same thing for matrix B. So we got to type that in. So second, and then matrix B. So before I go down to matrix B, go over to the edit menu and then go down to B. Do it in that order. Go to the edit menu, down to B, and either press enter or type the number 2. Now matrices are rows, the number of rows by the number of columns. Matrix B for us has how many rows and how many columns? How many rows? 3 rows and 1 column. So let's type in that we want a 3 by 1 matrix. Now if you screw up, if you accidentally type in a 1 by 3 matrix, look what your calculator does for you. It gives you what it asks, but you look at it and go, wait a minute, that's backwards. I need something tall and thin, not wide and short. So go back and do a 3 by 1 matrix. There you go. No big deal. 6, 8, and 9. And again, you need to exit this. You need to get out of it. What was the trick to get out of this? Second, and then mode key. Good. Now all that's left is to calculate our solution. We need to calculate A inverse B. So we're going to have to go back to that matrix menu a couple more times, but watch how easy this is going to be. Press the second button, then matrix, then either type the number 1 or press enter. But from here, that'll put matrix A on our home screen. We don't just want matrix A, we want A inverse, right? Can anyone tell me where the inverse key would be? Anyone at all? It's right on the face of the matrix key. So type the inverse key, but I want A inverse times B. Now on your graphic calculators, you don't need to hit the times. It understands that 2 things written next to each other are going to be the times. So go back and type in matrix B now. Type it in the same way that we did with matrix A. Second matrix, this time go down to 2, or simply press the number 2. You've got A inverse B. Are we all together on the same page here? Yes, sir. The inverse button is right here. It's right on the face of the key that we use to get to the matrix. And then type in matrix B. Now this is the big finish. Are you ready? Press the enter button. Booyah. There's your solution. 1, 2, and 3. Cool. And that's it. You're done. Did anyone else not get those answers? If you didn't get your answers, one possibility is that you might have typed in matrix A wrong. And to check that, to check before you even do this, you know what? I better make sure I got this right. what you can do is type second button and then matrix, and then just type the number 1 or press enter, and then press enter again, and that'll print out matrix A for you, and you can double check that you entered what you thought you entered. Okay, so that's what threw things off. It's not a bad idea to do that for matrix A and B, although it's up to you. But that's it. We've solved our system of equations. So 1, 2, and 3. You can check back here. Yeah, 1 plus 2 plus 3. Yeah, that's 6. 1 plus 4 plus 2. 1 plus 4 plus 3 is 8, etc. It works in all 3 of our equations. So you're done. 1, 2, and 3. And what I want to do is I want to practice this a couple more times for different systems and show you something else that can happen. But this is what I'm looking for from you in this section. Now, I will tell you this. We are bypassing a ton of work. Finding this inverse is a big chore. It's a real tough calculation. Even for my college algebra class, I kind of water it down. So we're skipping a lot. But this is a cool trick to know. Let's try it again. Is there anything about problem 30 before we move on and try, say, problem 50? Let's look at problem 50. Two x plus 3y minus 2z equals 18. 5x minus 6y plus z is 21. 4y minus 2z equals 6. Now, unlike the book, I actually took care to write things in nice, neat columns. The first thing we have to do is we have to write this with matrices. So basically I need matrix A and matrix B. What do my new A and B equal in this particular one? Norm? Want to give me A? Go ahead. 2. Good. Good. Thank you. And 18, 21, and 6. So go back and edit your matrices. Put in these new numbers for A and B, and then go back and solve for our system of equations. So once again, press second and then matrix. We want to edit a 3 by 3 matrix. Since we don't need to change the dimensions, we can just kind of cursor down and enter in 2, 3, -2, 5, -6, 1, 0, 4, -2. Very important. Once you're done editing that matrix, quit. Don't try and jump right to matrix B. Just exit out of here. So hit the second button, then the mode key to exit out of there. Then go back and edit matrix B. B is still a 3 by 1. This time it's 18, 21, and 6. You can, if you want, type out matrix B and matrix A. Let me just do matrix A. 2, -3, 2, 5, -6, 1, 0, 4, -2. Looks pretty good. I'll do likewise for matrix B. Just print those out. Matrix B lines up as expected, 18, 21, 6. Let's clear all that out and then type in matrix A and then the inverse key and then matrix B. What'd you get? Good. 8, 4, 5. Wow. 8, 4, 5. Like that? It's pretty good. It's a good trick, huh? It's like, man, why didn't you tell us that last person? Sorry, it takes a while. A couple more here. Let's do problem number 28. So 5x minus 4y equals 10, and x minus 7y equals 2. What are a and b going to equal for this system of equations? Good. 5, negative 4, 1, negative 7, and 10 and 2 respectively. When I go to enter these in my calculator, I hit the second key, then the x inverse key to get to this menu. I'm going to edit matrix A. What change do I need to make? Say again? Got to edit the columns and rows. What's the appropriate numbers up here for this one? It's going to be a 2 by 2. So 5, negative 4, 1, negative 7. Exit. And then go back and edit matrix B. Camila, what size should matrix B be? That's 2 by 1. So 10 and 2. So then I want to type in A inverse times B to get my solutions, 2 and 0. All right, so the point of this is that you can do this for any size system of equations you want. If I gave you a 2 by 2, 3 by 3, 4 by 4, it works out the same. So in this particular case, we got 2, 0. Okay, great. Now, would you choose to solve this that way on an exam? I don't know. If I gave you this problem number 28 and said solve it, would you take the time to do it that way? I wouldn't. No. I mean, addition method looks pretty good. Substitution method looks pretty good. Yeah, I'd do those above that. But it still has its place. The unfortunate thing is you can't use this for like everything. You're going to run into problems. Let's take a look at problem number 34. Negative 6x plus 12y equals 10. And 2x minus 4y equals 8. Now let me just do this one up here. You can do it yourself if you want to try and keep up. So we want to enter in the matrix system of equations. The matrix that will go with this one was negative 10, excuse me, negative 6, 12, 2, and negative 4. And B is 10 and 8. Just enter matrix A. Just enter matrix A. Don't bother with B. Matrix, over to edit, 2 by 2, negative 6, 12, 2, negative 4. You can type out matrix A. So second matrix, make sure you got it right. In fact, why don't you practice that? Practice typing out matrix A. See if you got it right. And then hit the inverse key. The inverse key is just x to the negative first power. It's on the left-hand side. It's the key that we've been hitting to get to the matrix menu. If you type that, it's going to take the inverse of your matrix. It's going to calculate that. But what happens when you do that? What'd you get? An error. Now that's different than most of our experiences. Usually when we want an inverse of a number, we can find it. The only exception to that is 0. Well, this is kind of like the matrix equivalent of having a 0. We can't take its reciprocal. We can't find its inverse. You have a singular matrix. You're getting an error. Why is that? Can we look at this system of equations and figure out what might be going wrong? How come I'm not getting two lines that cross each other? Close. If you multiply the bottom equation by -3, I'd end up with -6x plus 12y equals -24. And when I compare that to -6x plus 12y equals 10, I'm pretty close, but I don't have the right-hand side. So, what that's saying is that the lines are parallel. The bottom line is that there's no solution. They do not intersect. Now, if multiplying by -3, I got the same number on both sides, then it'd be one line on top of the other. Okay, so that's when you would get that. So, I mean, the inverse matrix is really cool, and I love introducing it. I'm not going to ask you to calculate it by hand. Do you want one more example with the inverse matrix, or are we good on that? We're good? You're confident so that if I gave you a system equation that said solve using the inverse matrix, you'd be able to solve it this Wednesday. All right. I don't know how much trouble or help they're going to be able to give you on that in the lab, but hopefully you're good here. So section 12.4 homework. Try problems 27 through 31. Now you're going to get solutions to these. 33, why isn't there a solution? Let's do that for 33 and 35. So I'm telling you right away, don't bother to solve those because you're not going to find a solution there. One last one you should try. Problem number 51. And the reason behind that is that you've kind of got to do what we did, or what I did with problem 50, and that is be a little bit careful in setting things up. The system of equations there is y plus 2z equals -2, and then x plus y equals 1, and finally 2x minus z equals 0. Is it 52? All right, well, do 51 anyways. Same thing, but let me explain here what I wanted to get at, and that is your matrix. There'd be a 0 for x, 0, 1, 2, and then 1, 1. There's no z's, so that'd be a 0. 2, 0, -1. So that would be your A for system equations like that. You're going to have to do something similar for problem number 51 as well. Okay.